Welcome to the Create a Depth Grid from DFIRMs video tutorial. In this video, we will walk through how to create a depth grid in ArcGIS using Digital Flood Insurance Rate Map or DFIRM data, including brief overviews of flood zones and data in the DFIRM database. There are 3 data sets that you must prepare before building your depth grid. This process should only be used if depth grid information is not available from the non-regulatory database or if other engineering grade data are not available. First, you should have a predefined area of interest, or AOI, for your study region. This is a simple polygon feature class that specifies the geographic limits of your depth grid and its geographic coordinate system. The AOI will save time when creating your depth grid by reducing the amount of calculations that Hazus will have to perform. Second, you should have the National Flood Hazard Layer, or NFHL data, for your study region downloaded from FEMA's Map Service Center and converted to NAD 1983 Geographic Coordinate System. The NFHL includes 2 files, cross-sections and flood hazard area, and both are found in the DFIRM database accessed via the link in the video description. Finally, you should have a digital elevation model in feet, or DEM, that covers the area of your AOI. Once your data is prepared and in the correct projection for Hazus, you can begin to create the depth grid for your area of interest. We will be creating a depth grid within Salt Lake County, Utah, and this video will demonstrate how to create the AE flood zone depth grid. You may have other flood zones, such as AH, AO, and A, which will need to be processed individually and then merged together to form the final, complete depth grid for your AOI. As a reminder, this is done in ArcGIS, not in Hazus, and instructions on how to process each flood zone type can be found in the Flood Level 2 SOP accessed via the link in the video description. First, you must define the boundary for your AOI by clipping the hazard area file to your AOI. Open the Geoprocessing menu and select the Clip tool. Click the folder icon next to the Input Features box and select the S-Flood Hazard Area shapefile from the downloaded DFIRM data as the input feature. Then select your AOI file for the Clip Features parameter. For the Output feature class, choose a destination and name it AOI_clip or another easily identifiable name. Click OK to run the tool. When finished, you will see the layer automatically added in your table of contents. You can now remove the hazard area layer. Next, you must extract the flood zone data for the 100-year flooding event within your AOI. With your newly created clipped AOI layer selected, open the Selection menu and click Select by Attributes. Scroll to and double-click Flood Zone to enter it into the query box. Then click the Equals button and click the Get Unique Values button to see the different flood zone attributes in the AOI. In this scenario, we have 4 types of flood zones: A, AE, AH, and X, though there may be more for your region. The values with the letter A in their classification designate areas that are within a riverine 100-year event flood zone, whereas other values, such as X or V, designate different flood zone areas. To build a depth grid for a riverine 100-year event, we would want to individually extract all attributes with the letter A and process each zone separately, then merge them to create our final depth grid. However, we will only walk through the AE zone in this video, so we will double-click AE to complete the query and click OK to select the AE flood zones in the map. Now, export the AE flood zone selection to a new feature class by right-clicking the AOI clip layer in the table of contents. Hover on the Data submenu and choose Export Data. In the Export Data dialog box, select the radio button next to the data frame, specify the save destination, name the file AE Zones, and click OK to save the feature class. Click Yes to add the new layer to the map. Repeat these steps for each of the different zones in your AOI and export each as their own feature class. You will use these data to create their respective depth grids before merging them into a final depth grid for the whole region. You can also create an inundation boundary at this time by using the Select by Attributes tool to extract the area labeled as True within the SFHA category of your clipped AOI file. In the same way we selected AE zones, create the query SFHA_TF equals T and click OK. Export and save the layer, naming the output file SFHA_T. You can now remove the AOI_clip layer from your table of contents. To turn the SFHA_T layer into the inundation boundary, open the Geoprocessing menu and select the Dissolve tool. Select SFHA_T for the input feature and then specify the output feature class location using the name Inundation Boundary. Click OK, and a single polygon will be created that represents your area of interest inundation boundary. You can now remove the SFHA_T layer. Once you have exported all of your relevant flood zone data, you will need to define the flood elevations of each zone and combine them into a single depth grid. We will continue with just the AE zone in our video, but the processing instructions for all zones can be found in the Flood Level 2 SOP accessed via the link in the video description. To begin processing the AE zone, we need to clip the cross-section information to the shapefile we just created. Return to the Clip tool. Select the S_XS layer as your input features. Select AE_zones as your clip feature. Select your save destination and name the output XS_clip. Click OK and the layer should appear, showing the cross-sections as lines across your AE flood zone. In order to create a depth grid from the cross-section data, these lines will need to be converted into points. In the Search panel, search for the Feature Vertices to Points tool. Enter your cross-section_clip layer as the input feature, specify the save destination, and name the output cross-section_points. Click OK, and the tool will turn the endpoints of each cross-section line into a point that can have an elevation value assigned to it. In the Search panel, find and open the Extract Values to Point tool. This will allow you to extract data from a file and assign it to point locations like our AE zone cross-sections. Enter the cross-section_points layer as the input feature and the DEM file as the input raster. Specify the save location, name the output cross-section_values, and click OK. The tool will determine and assign the DEM value at each feature point. You can remove the S_cross-section, cross-section_clip, and cross-section_points layers from your table of contents. Now, you will need to interpolate the water's surface elevation between these various points, creating a raster file. Open the IDW tool from the Spatial Analyst toolbox. Select the cross-section values layer for your input point feature and set the Z value to raster value, indicating it is referencing the point's water surface elevation. Specify the save location and name the file AE_zone. Next, click the Environments button. Expand Processing Extent and select Same as the layer AOI in the Extent dropdown to define the area of interest boundaries as the extent of your interpolation. In the Snap Raster dropdown, select the DEM file. Then, scroll to and expand Raster Analysis and set the output cell size to same as layer DEM_feet. Accept the new environment settings by clicking OK, then click OK again to run the tool. The new layer will appear in your map. Defining your environment settings is important because identifying your AOI as the masking parameter will limit the size of your raster creation and drastically reduce time to create your file. If you did not specify an AOI, this process would take several minutes to several hours to calculate for the entire DEM area. Make note of these settings as you will need to repeat them for future processes. Now, you can use all of the data you created to build your AE zone depth grid. First, you will have to determine the height of the water above ground in the inundation zone. From the search panel, find and open the Raster Calculator tool. Here, you will create an equation to subtract the DEM height from the water surface height that you just created in the previous step. Double-click the AE_zone layer, click the minus sign, and then double-click the DEM feet layer. This will subtract the DEM from the interpolated water surface height, resulting in the depth of water. Enter the file name as IDW_minus_DEM, set the environments as we just did for the IDW, and click OK to run the tool. The layer will be added to your table of contents. Next, you will have to use the raster calculator on this new layer to create a layer of only the locations where the water height is higher than the ground height. Return to the raster calculator and create a new equation to remove areas where the height of the DEM is above the height of the water surface. Double-click the IDW_minus_DEM layer, then click the greater than or equal to sign and the number 0. Enter the file name as AE_non-zero, set the environments as we did for the previous calculations, and click OK to run the tool. This will remove all negative values from the raster and identify areas where the water elevation is higher than the ground elevation. Your view will now display all areas within your area of interest where the water's elevation would be higher than the ground's elevation. The raster is a true-false raster where 1 represents where the water is higher than the ground's elevation and 0 represents where it is not. We need to convert this raster into a vector polygon using the Raster to Polygon tool. Enter the AE_non-zero file for your input raster. Make sure to select Value from the field dropdown and uncheck the box next to Simplify Polygons. Enter the file name as AE_non-zero_polygon. Click OK, and the tool will convert the true-false raster into a true-false polygon, where 1 still represents areas where water elevation is higher than ground elevation. We will use this polygon to identify the areas with a positive flood depth by extracting these 1-coded values. Reopen the Select by Attributes tool and select AE_non-zero_polygon as the target layer. As we did before, create the query gridcode = 1 and click OK. Export and save the layer as gridcode 1. Now we will begin the process of creating the AE flood zone depth grid by clipping our water height data to this polygon. Open the Clip tool, select gridcode 1 as the input feature, and AE zone as the clip feature. Enter the file name as AE_clip and click OK. Next, open the Extract by Mask tool. Set the input raster to IDW_minus_DEM and the feature mask data to AE_clip. Enter the file name as Extract AE zone, set the environments as we did for our previous processes, and click OK. This new layer has extracted the data from the water height raster and clipped it to the areas in our AE zone that were identified as having a positive flood depth. We need to create a 0.1-foot height infill for the area of our AE zone that we identified as having a negative flood depth. essentially filling in spaces in our AE zone depth grid that will not have a flood height. Open the Erase tool and set the input features to AE_zone and the erase features to grid code 1. Save this file as AE_zone_erase. Now return to the Extract by Mask tool. Set the input raster to DEM_feet and the feature mask data to AE_zone_erase from the previous step. Enter the file name as ext_non_AE, set the environments, and click OK. The layer that appears represents the area of the AE zone where the ground is higher than the water and the value is the ground height. Next, change the value of the height to a constant depth of 0.1 feet. Open the raster calculator, double-click the new ext_non_AE layer, and then type is equal to 0.1 in the expression field. This will set the ext_non_AE raster equal to a constant 0.1 depth in feet that we will merge with our raster of positive flood depth in order to create a complete depth grid for the AE zone. Enter the file name as infill, set the environments, and click OK. We now have two rasters. The first raster, Extract AE Zone, represents the AE flood zone depth grid, and the second raster, Infill, represents the areas without a flood depth that fills in the rest of the AE zone. To merge these two together, open the Mosaic to New Raster tool. Enter Extract AE Zone and Infill as the input rasters. Enter the file name as final_DG_AE. Set the number of bands to 1. Finally, set the environments and click OK. When processing is complete, your new complete AE depth grid layer will be added to the map. If your area of interest has only one flood zone, then you have a final depth grid. However, if you have multiple zones, follow the steps laid out in the SOPs to create their individual depth grids, then use the Mosaic to New Raster tool to merge them all together into your final depth grid. Congratulations! In this video, you learned how to create a depth grid in ArcGIS using DFIRM data. Look for more Hazus video tutorials on the FEMA YouTube channel.